Hi everyone, my name is Jack Hessel and I'm a research scientist at AI2. I'm super excited to be here today to present Do Androids Laugh at Electric Sheep? Humor Understanding benchmarks from the New Yorker Caption Contest. This is joint work with a lot of awesome collaborators from the University of Utah, Cornell University, University of Washington, Airmail, and OpenAI. Have you heard the news? Large language models can now generate and even explain jokes. If you log on to ChatGPT and ask it to tell you a joke, it might generate something like this. Why don't scientists trust atoms? Because they make up everything. Even beyond generating simple jokes like this, some language models have even successfully explained jokes before. Here's an example from Google's 540 billion parameter PaLM language model. In this case, PaLM is attempting to explain a joke about TPUs, which coincidentally is the type of hardware that the model was trained on. I would argue this is a successful joke explanation. This capability was actually highlighted at Google I/O, which is Google's developer conference. Here's a picture of Sundar Pichai touting joke explanation as an interesting capability of PaLM. This public-facing declaration of capacity led to headlines like, "No joke, Google's AI is smart enough to understand your humor." But do large language models really understand humor? If you play around, for example, with ChatGPT and probe at its humor understanding capacity, for example, by asking it to tell you a knock-knock joke involving a pineapple, you might be a little bit disappointed. Here, ChatGPT appears to paste the word pineapple into some sort of knock-knock joke and then claims that it's made a pun, but it doesn't quite make sense. I personally don't see the pun here. Now, I'm not going to tell you this isn't an objectively funny output. It's a little bit absurd because there isn't a pun, and I am a fan of absurd humor. But the fact that the language model is claiming that there's a pun really calls into question whether or not ChatGPT understands what's going on here. To probe at this in a more structured way, we turn to the New Yorker Caption Contest. The New Yorker is a magazine which has been publishing cartoons since its inception nearly 100 years ago. More recently, starting in the mid-90s, the New Yorker Caption Contest has been run through the magazine as well. The contest works like this. Each week, a captionless cartoon, like this cheese sailing one, is published in the New Yorker, and readers are invited to submit their best captions for that cartoon. Then, the editors select 3 finalists, and a final vote determines the ultimate winner. This is a very popular contest, and they get thousands of entries from all across the country and really the globe, including famous celebrity entrants like actors and former presidential candidates. So this is very much on the public consciousness. So what do we do with the New Yorker Caption Contest data? Well, we operationalize it into 3 different tasks. For the first task, which we call matching, we present models with 5 choices of captions, only one of which was truly written about a given cartoon. Next, we consider quality ranking. Here, we present 2 captions that were both written about the cartoon, but one was judged by human raters to be much higher quality. These human raters, in some cases, are the New Yorker editors themselves, and in other cases, this is done by crowd voting. Finally, we have an explanation generation task where we prompt the language model to generate a 2 to 4 sentence explanation of why the joke is funny. To support computational experiments on the corpus, we gathered a new set of annotations. In particular, for each of over 700 cartoons representing more than a decade of caption contests, we collect locations, descriptions, uncanny highlights, and entity links for each of the cartoons. Also, we collect a corpus of joke explanations, so we have a set of over 650 2 to 4 sentence explanations of jokes that we use. So how well do language models do at our various tasks? We'll look first at matching and quality ranking. On the matching task, our best model, which is CLIP, fine-tuned on the corpus we annotated, achieves around 62% accuracy on this task. This is relative to a 20% random guessing baseline, that's 1 in 5. However, humans get around 94% on the same task, representing a big gap in humor understanding. Now, you might be wondering, how well do models that don't have to do computer vision do? We wanted to test models like GPT-4 on this corpus, but GPT-4 can't take in pixels directly. So separately, we also consider a setting where we take language models like GPT-4 and condition them to do the exact same tasks, but give them a human-authored description of the image. Even with this additional annotation, there's still quite a big performance gap between GPT-4's 5-shot performance and human on the matching and quality ranking tasks. Speaking of GPT-4, let's take a look at some of its joke explanations for our third task of explanation generation. Here, we prompted GPT-4 to generate an explanation for this cartoon and caption, "He'll be back." You can see some errors highlighted. So, for example, GPT-4 claims that the customer is the one saying he'll be back, when I would argue it's pretty clear it's the people who are working at this establishment are saying this. And there are a few other errors as well. This is borne out in human evaluation experiments, where in a blind A/B study, human explanations are preferred to 5-shot GPT-4 explanations in more than 2/3 of cases. Overall, we're super excited to see what folks do with our dataset. We have a leaderboard and models available at this URL. And yeah, thank you so much for your attention, and I look forward to seeing you at ACL. Thank you.